Can everybody mute themselves, please, unless you have a question or whatnot. Um, but yeah, so we're gonna go ahead and get started. So today might be short, maybe I don't know. We'll see. We'll see what happens. But yeah, yesterday we went over the auction contract with Sahil, and today we'll be going over some more things that you can do with Solidity. We'll be going over like default values, the constant keyword, immutable keyword, what modifiers are, ternary operation, and conditional statements using if, else, while, break, continue, and doing for loops. All right. So yeah, this might be a light day, but anyways, so let's get into like default values. Um, let's see, u int number. I always like to start off with this example. All right, make this public so it's visible. All right. So we go ahead and deploy this. All right. As you can see, I didn't assign this any value. And boom. So for uint, right, the default value will be 0. All right. Same if we do ints, even though you will very rarely see ints. Yep, same thing for that. Let's see. Now, say if we do address, I'll just do owner, I guess. Deploy, boom. Yeah. So if you don't give address a value, it will be this. All right. Yeah. And also,
Address.
what was that?
I said if you don't give address a value, it would be null address by default.
Yeah. And also, this equals, let's see, 0x000 equals address 0. So yeah, let me make a function with the I don't know, address boolean, I don't know. Just give it a random function name. View returns bool return owner equals address 0. See what happened here. Oh, there we go. All right. So yeah, if we go ahead and do this, boom, true. So yeah, um, a null address, right, will equal this. All right. So this is something special. I guess you could say that you could do in Solidity when basically the address is nothing. All right. When the address basically doesn't exist, or is as like default value or whatnot. Let's see. What are other uh bytes public bytes? Oh, let me give this another name. I don't know, 1 byte, some byte. Yeah, I'll just do that. Yeah, but the default value will be 0x. Just like how 0x, this is what you'll see like, for like your public address. I'll probably do one more example. Let's see, we have uint address bytes. I'll do string, let's see, I don't know, string public greeting. All right, deploy again, and boom. So yeah, this is the default value for if you don't set a value to a string. So yeah, I'm pretty sure there's some data type that I'm missing, primitive data type. But anyways, the point is, um, when you don't set these with like a value from the start. I don't know why I keep doing it every time. But anyways, yeah, every time, yeah, if you don't set these equal to something, they will have a default value. You know, keep that in mind when you're making smart contracts, right? Um, Numbers they always gonna equal zero as a default. A string isn't going to equal anything. It's gonna be empty. Owner is gonna have this value here. Byte, right? Is gonna have 0x. And then here I made a function here is showing that the default value, right, for an address will be address parentheses 0. All right. So yeah, just keep in mind that there are default values in Solidity. All right. Um. So yeah, now that we've stopped talking about that, now that we're done talking about that, we will now get into the constant and immutable key values. All right. So
MJ, sorry, it's address 0 is MST sender or is it coming from directly Solidity? I don't understand. Address 0. Can you explain this a little bit?
It's coming from Solidity. Use of actually address of 0 actually represents a null address. That means OX000. It's called null address. So no value is assigned. When no value is assigned to an address, it's called null address.
Oh, okay, thank you.
yeah. So yeah. Let me kind of show that again. So address, right? So I just named a address name owner, right? And as you can see, I didn't give it no value. I didn't give it no value. And the address equals 0x00000. And what I was saying here is that 0, so owner equals 0x00000. And I was saying that that this equals this. So address parentheses 0. That's all I was trying to say. And that's something this is something that you'll see when you mess around with smart contracts or you see somebody's code, anything like that, Um, and a use case for that, will be to like say you wanna I don't know, transfer ETH or something, right? You wanna or say you wanna like enter a game or something. Maybe you wanna put a required statement saying that you don't want message.sender to equal address 0, meaning you don't want message.sender to be a null address, an address that doesn't exist. So yeah, I feel that I think that's a pretty nice use case for it. Yeah. So, um, does somebody have a question? Sound like somebody muted themselves.
That first we are declaring the address as above in the contract, then we are initializing its value to the owner variable. Is that correct?
Yeah. So address public owner it has no value right now, and I didn't set owner. I didn't assign owner with a value, but yeah. But yeah. I mean, you can if you want to. But all I was doing is just saying that owner equals uh the no value, meaning address 0. I hope that made sense. This is just me returning a boolean statement, basically saying if this is true or false. That's really it.
Okay, okay,
Yeah.
okay.
That's not me giving owner a value. That's just me doing that true or false statement. Um But yeah, anyway, I hope that makes sense. But yeah, let's get into constant and immutable without wasting too much time. So anyways, I'm gonna set this for constant. All right. Uh, let's see what happened here. Uninitialize. Okay, I'm actually not sure what is happening. Oh, I gotta give this a value. I believe that's the case. Yeah, there we go. All right. Um, all right, so function. So we'll do a little, we'll use a function, right, where you can change the number, right? So we'll use number 2, all right? Let's see, uint num. And if you remember from like the simple storage contract, right, you can use functions, right? You can change the value of a variable, right? So we'll do number, number 2 equals num. And then, yeah, so whatever, let's see what the problem is here. Oh, all right, there we go. I'm so used to doing uint. But yeah, all I'm doing here is that whatever I put in for here, this number 2 will equal, what I put in here for the parameter. So as we see, right, now this is valid, right? I'm not getting no errors in Solidity, right? But say if I wanted to change number, right, and the key, it has the key value, or it has a key word constant, right? So if I do that, so change, we'll do change constant number, uint, constant num. And once again, you don't have to do these underscores. I just like doing it personally. It helps me. But anyways, so we'll do number equals constant num. All right, so check this out. So as we can see on line 23, right, I am getting a type error saying cannot assign to a constant variable. All right. So basically, what this means is that when you assign constant, when you assign the constant keyword to a variable, right? In this case, I'm doing that to number. This means that this value is permanent, meaning that this value can never change. All right. It's kind of, I always refer back to JavaScript. If you know the keyword constant, right? Like const, C-O-N, what is it? C-O-N-S-T, right? You'll see this in JavaScript, meaning that like you can't, sort of like you can't reassign that variable with another value, right? It's basically the same principle with the Solidity. When you use the keyword constant for a variable like number here, I gave it 10. This value 10 can never change. All right. So and yeah, once again, that's why Solidity is throwing an error because I'm trying to change number, but number has the constant keyword. Now, if I were to remove this, now it's not giving no errors because I removed the constant keyword, and I can change the value now. Anyway, so we're gonna, I'll just comment this out to show. All right, so that's constant, right? So now let's get into immutable. All right, so for this, we're going to use the constructor. All right. We'll do. I'll use greeting for this example. All right. So we'll do string memory new greeting. Let's see. We'll do greeting equals new greeting, and let's see. Mutable. Let's see what's going on here. Non-value type. Okay, what if I did? Okay, maybe let's try doing wait, let me try this. Let's set this. Let's do owner. Alrighty, so as you can see, I have, I put mutable. I'm not sure why it wasn't working for like the string variable. Maybe you can't use immutable for string data types. But anyways, I set a mutable keyword to owner and address, right? And basically what this means, so constant, well, immutable is very similar to constant, right? But immutable is for those, immutable is for like variables for when you set the variable, when you define, or revalue the variable inside a constructor. So yeah, immutable, once again, immutable is what you will only use when you want to set the value of the variable inside the constructor. Does somebody have a question? Nobody had a question? All right. Yeah, hopefully that made sense. And once again, I'm not sure why when I tried to do the string value or the string variable, it wouldn't. I was getting that error. So yeah, that's immutable. All right. Constant and mutable, they are very similar. Immutable, you will only use immutable when you are using the variable for the constructor. All right. All right. So now we are going to get into modifiers, and I kind of, I guess I really can't really do about it now, but I probably should have mentioned modifiers early on. But all right. So let's see. All right, we'll use this function as an example, right? So so I have the owner, right, and owner equals message.sender. So we haven't talked about required statements yet, but I'll do, let's see, message.sender has to equal owner. You are not the owner. All right, there we go. All right, so basically what I'm doing here, right? So we'll get into. I haven't talked about like exception statements or whatnot, but basically what I'm doing here now is that the message.sender, basically the address that is trying to execute this function, they have to equal the owner, right? And if they are not the, say it again. Did somebody want to say something? Or I guess not. But anyways, with this required statement, all I'm saying is that the message.sender, the address, the person that is trying to execute this function, they have to be the owner, and if not, it will throw an exception saying that you are not the owner. And I guess I could demonstrate that a little bit, right? So when I deploy this, the owner will be set to message.sender. It will be, I'm going to deploy it with this address. And as you can see, if we type on owner, boom, that's the address, all right, of owner. Now, say if I mess around with this function, right? Say if I were to change the address, say I want to change number 2 to 2, and boom, I get an error, and it should be a message somewhere. Yeah, here it is. You are not the owner. But if I actually switch to the address that is the owner, all right, change the number, and it accepted it, and now number 2 is 2, right? So yeah, you'll see this a lot. But another way I can do this is that I can make it. I can I can specify a modifier. So yeah, let me make the modifier and I'll further explain it. All right, so modifier only owner, boom, require message.sender. All right, there we go. All right, so what is a modifier? A modifier is basically something that you can, add to like your function signature, and you can add it to any function in your contract, and it's usually like it's it's kind of act as like a required statement. Well, I'll never really explain required statements yet, but it's basically saying with modifiers you have to bypass the rules of the modifier, or like the function has to bypass the rules of the modifier, right? When it's in the function signature. And what I mean by function signature is this. So we can add a modifier to a function like this. So I'm putting the modifier only owner into the function signature, all right? And now that I have the modifier here, instead of yeah, now that I have it there, I can basically remove this, all right? And and just to show that it works, just to show that this required statement will still work like before, we'll do deploy. So the owner is that's, and once again, if I try to use an address that's not the owner, it will fail. All right, and yeah, once again, I have only owner as a modifier, and once again, yeah, I have to be the message.sender, the person that's executing the function has to be the owner. I guess I could do another modifier example. Oh yeah, also this underscore, you always have to put this underscore here, right, with the semicolon. And I'm actually not 100%. I'm not 100% sure what this means, but I believe this is just saying that I believe this is just like all of the code that comes after um this here, whatever specify above the underscore or whatnot. This is the code. So like in this case, with function change number, the underscore will represent number 2 equals underscore num semicolon. And I guess just to showcase another modifier, we'll do and why am I spelling it wrong? Anyways, so modifier, let's see, can't be, I don't know, 0. We'll do required, I don't know, message.value has to be greater than or equal to 0. We'll do you are not sending anything. And to test out this modifier, we'll do function pay contract. Let's see, public payable only owner. No, not only owner. Can't be 0. Let's see. Yeah. Actually, that might be a little confusing, but and then I'll just make another function to get the balance of the contract. All right, let's see. So I should still be able to use this function, but yeah, try not to get too confused at the fact that I don't have anything inside of this. But all I'm really doing, I'll mark it as payable, right? And because I have payable in the function signature, this is allowing me to be able to send money to this contract, and the contract in this case is conditionals. So yeah, we'll deploy. So as you can see, the contract balance is 0, right? Is 0. All right. So now, once again, we have this modifier saying can't be 0, meaning that I cannot send 0 way ether to the contract, right? So say if I try to do that, so pay contract, oh, I need to put greater than instead, actually. So yeah, let me do that again. And yeah, there we go. So yeah, it's saying you are not sending anything. And yeah. And that shows that the modifier is working in this function. So now if I send something greater than 0, all right, pay contract, and boom, it went through. And now if we look at the balance of this contract, right, boom, it is 1. So yeah, these are examples of modifiers. I would say they're optional. I would say what can make modifiers powerful is that say you are constantly, so like this require statement here, right? You might be constantly using this same line in a bunch of functions, right? But to make that even easier on yourself, you can just, make a modifier with this statement. And then, whatever function needs this require statement, you can just put in function signature, and, that will save you a lot of time in writing code. So I would say that's the powerful use case of modifier. So yeah, those are modifiers. Pretty simple examples. Only owner, I would say, is the most. Only owner is like the biggest modifier example you'll see. All right, so now we'll get into if and else. I know I have ternary operators here, but yeah, we'll do if and else first. All right, so let's see. Let's make a function. Let's see. Return different message. Public here. Let's see. I don't know, we'll do if number equals 0, return true. Else if number is greater than 0, return false. Let's see. Actually, we'll do. All right, there we go. So let's mess around with this function. All right. So deploy. Return different message. All right. So currently number 2 is 0, right? And because that is the case, it should return true. And now, say if I mess around with this function again, right? Change number. If I hit this again, wait. Yeah, if I hit this, boom, it should return false. But yeah, this is a very simple example of using an if-else statement. That's pretty sure you'll see this in every single coding language. Yeah, just like JavaScript. Yeah, if, else, and when you are, like comparing like a variable to like a value or whatnot, you will use double equals, right? I know with JavaScript, right? So I'm pretty sure a lot of people, um they know JavaScript, right? You will see, like the triple equals, right? But in Solidity, that's not the case. You will never see a triple equal when it comes to conditional statements. Because the thing is with like JavaScript, it needs that to compare like I don't know, like the type, like the data type. So Even though this isn't a JavaScript class, I actually kind of want to show that. Oh my gosh, all these errors. Let me clear this out. Anyway, so 1 plus 1, right? So yeah, JavaScript, you'll have this issue here, right? Really, this should be 2, but it's 11. And JavaScript, it can't really detect it unless you like put triple equals in like a conditional statement. But in Solidity, you won't have that issue. So yeah, you'll use double equals or whatnot. So yeah, that's a simple conditional statement. All right. We'll do for loops. All right, we'll do a for loop example. I'll create another number. Let's see. uint for loop number. Alrighty. So let's see. We'll just name this for loop example public. Alright, so this is how you make a for loop statement. Let's see, I less than 10, I plus plus. We'll do, okay, what's the variable name again? For loop number. For loop number. Alrighty. And let's make this public so that we can view the value of it. Alright, so we'll deploy again. Alright. So as you can see, let's see, for loop number equals 0, right? But, so it's 0 now, but if we run this function, this for loop function, alright, let's see, where is it? Boom, execute that. And, oh, I need to increment it. My bad. But yeah, once again, this is 0. And now if we hit this function, boom, now it is 10. Alright. So yeah, this is, once again, this is how you write a simple for loop like statement here. So you had to give, so I is short for, I guess, iterator. Alright. So you have to put the variable type, right? Uint equals 0. Alright. Well, you can say 0, 1, 2. Most of the time you'll see 0. There are times where you'll see 1, depending on the use case. I is less than 10. Alright. And then I plus plus. So what this means here is that the iterator is starting from 0, and that this is going to run, and since it says I is less than 10, and that I am incrementing the iterator, this for loop will run 10 times, and it will increment the for loop number 10 times. So yeah, that's what this means here. I'm running this for loop 10 times, and every time I'm running the for loop, I am incrementing for loop number 10 times, and yeah, that's how I went from 0 to 10. Alright, so yeah, that's a for loop example. Let's get into like while break.
Larry, I've heard that we do not usually use the if-else statement because it costs a lot of gas fees. Instead, we use required statement. So is that true?
Yeah, I actually almost forgot to get into like gas in terms of using conditional statements. Um, let me actually introduce that. So and I know we haven't talked about like required statements yet. Um, Now, require and if and else statements, they are, or I should say if statements, but require and if statements, they are pretty similar, right? Um, but the difference between if and require is that if is optional, if is like situational, right? If might not even execute depending on what you type inside of here. However, require, like it says, require meaning that it has to run. All right, require meaning that this has to be true no matter what. All right, and I guess too, required statement is something that was invented in Solidity because with Solidity, you are programming money, and you wanna like once again like with this here, you want to make sure that that person is sending more money or sending the right amounts of money. Say if they want to buy like a token or whatnot, you have to make sure that they are sending the right amounts of money. All right. Um. And yeah. If and else statements, also for loops. Um. You want to be careful with how you use them. All right. Only use them if you need to because, well, yeah, only use them if you need to because conditional statements and for loops they run a lot of gas. They use a lot of gas when they are executed. Um, yeah, and if possible, use a required statement. You know, required statement it saves a lot more gas, and if and conditional statements. I know one use case for like for loops is that there might be a different way to do this, but say if there's like 10 um say there's like 10 I don't know addresses, right, that have tokens, like they're staking tokens, right? Say if you want to pay all of those what you call it, say you want to pay all of those investors, right? You could run a for loop where you can pay them all at once. But actually, a safer way to do that will be to allow that address themselves, like allow the user themselves to claim that token. That way, you're saving way more gas than running the for loop because say there's like 1,000. Say in that case, there's like 1,000 addresses. Actually, let me see if I can make an example construct of that or an example function of that. So we'll do address, um, let's see, public. We'll do address, payable, public, investors. Let's see. All right, there we go. Let's see. We'll do pay investors, public. Pretty sure I have to put payable there for uint I equals 0, I is less than investors dot length I plus plus, and let's see, so we'll do investors I dot transfer 1 ether. All right, let me explain this. All right, so the iterator is starting at 0, right? And I am doing I less than investors.length. Now, say if there are 10 investors in here, right? This will be like I is less than 10, just like down here. So that means that if there are 10 investors, I am looping over this 10 times, and then, the iterator increment, so I got the R plus plus. And yeah, for every investor, right? For every investor that, what you call it, is in, for every investor that is in this array, they are getting paid 1 ether. So I know before introduced the call method, but I just did there's also the transfer method. So yeah, basically I'm running a for loop, and where I am paying 10, well, say if this was 10, I'm paying 10 investors 1 ether. But yeah, this could run a lot of gas. If this was like 100 investors running this function, it will cost like a lot of gas, like a lot of gas. Yeah, let me let me try to showcase that even further, because I know this log, it will show you the execution gas cost. So let's see. Um, Deploy. Let's see. All right, so we got investors. Oh snap! I need a way to push the investors. So let's do the push investors public uh investors dot push message dot sender. Oh snap! And what is the issue here? Oh, gotta mark this as payable. All right, there we go. Let's see. Deploy. And I'll just push some investors in here. So this one, push, boom, push. All right, so now we have 2 investors, right? We have 2 investors in the array. So if we run this pay investors function, all right, let's see, where is it? Pay investors, boom, and it failed. The called function should be payable. Let me try this. Oh, that doesn't work. Well, anyways, but yeah, basically, if I were to just do two investors, right, it will use, say, maybe it will use 2,000 gas, but then if I have 10 investors, it might use 5,000 gas. So yeah, the more investors that enter the contract, the higher it will be, the more it will cost to run that function. So yeah, I rambled on about that for like really a really long time. Anyways, let's see. Um, we'll do ternary operators. All right. Let's see. Function ternary function public view returns bool. Let's see. We'll do return number equals 0, true, false. All right, there we go. Let's see. And actually, let's do number 2. All right. So deploy. All right. So yeah, we're gonna execute this. All right. Boom. So yeah, it marked that Boolean is true because, and if we look at number 2, is 0. But if we change the number, all right, it will be false. All right. So now, what is ternary operators? So ternary operators, once again, this is something that you'll see in JavaScript. So this is what this means. So number 2 equals 0. If this is true, so the first statement. So if it is true, return true. If it is false, return false. And maybe I could do no. Maybe I can do memory. Let's see. Maybe I could return a string instead. This is 0. This is not 0. All right, there we go. So yeah, let's do this again. So yeah, number 2 is currently 0. It will return this is 0, and then once again, it is not 0 anymore. So now it will say this is not 0. So yeah, ternary operators, you'll see this in other languages. Basically, once again, if this is a statement here, right? If it is true, it will do this. And then after the colon, if it is not true, it will return this. It will do this. All right, so that's all that ternary operators are. I will say I still wanted to bring it up in this session, but ternary operators are very rare in Solidity. You will very rarely see them, I would say, but they still have their use cases. Well, you will see it, like, say you like messing with NFTs, you'll see it there, but yeah, you will very rarely be using ternary operation in Solidity, but it's still something that you can use in it. So yeah, we'll do while break continue. I know it's past the time now, but I'm gonna try to showcase these as fast as I can. Let's see. We'll do while example public. Let's see. We'll do while this. I don't know, while I is less than 5, return true. I don't know, we'll do break. And let's see. U returns boolean. Let's see. Oh, there we go. All right. Deploy. All right, let's see. Actually, how will this work? What will happen? Well, anyways, basically what's happening here, right? So it's the same as like this for loop, right? This is looping over 10 times, right? Except now we have this while statement saying if I is less than 5, we will return true. But then I have this break here, right? Break, that basically means that I am stopping the for loop. All right. And if I didn't put this break here, this would have kept continuing on forever. And just to show something a little funny, if I were to remove this and I did, I don't know, greater than 0, no, we'll do greater than -1. I don't even think, I'm not even sure you can do negative numbers like that. But say if I were to do this, and let's see. Okay, that didn't work. Okay, maybe I can do this. Oh well, but basically, if you make some type of conditional statement where like it loops on, where it can loop on forever, you will basically crash remix. So yeah, make sure you don't do that, and yeah, but yeah, for loops. Once again, for loops, conditional statements. You want to try and use those when it's only necessary, because this is Solidity. We are messing with the blockchain. Conditional statements, they can use a lot of gas, so use it when it's only necessary. And once again, for like conditional, like if statements, you want to try to replace that with required statements as much as possible. We haven't gone through like require, assert, revert. We will get into that in later sessions, but and I know I didn't really showcase continue, but continue, break, while, you basically also see those in a language like JavaScript. But yeah, I mean that's really about it. I went over default values, right? There's default values in Solidity. There's keywords such as constant and mutable. You can use modifiers. You can use ternary operators, and you can use conditional statements like you can in other languages. So yeah, that's really all I have. And yeah, if anybody has any questions, you can let me know. All right. Well, but it looks like nobody has any questions. Yeah, so I will push this to GitHub in like the next 5-10 minutes. You can view it there. Not sure not sure where Sahil is at, but of course tomorrow we will be doing another project. Yeah, let me see what the project is for tomorrow. Um, let's see. Tomorrow we will be doing an appointment scheduler contract. So yeah, stay tuned for that tomorrow. And
LJ,
yeah, yeah.
can you check the pair programming channel? I've sent the code snippet in which I am trying to run it with a for loop, but it's giving me errors.
Or yeah, I can I'll let me help you out with that after this. If
Okay.
if anybody else has any questions right now, I'll I'll definitely get to you. But yeah, it looks like nobody has any questions. Yeah, thank everybody for tuning in. Once again, made some little mistakes there. I'm a human being, of course. We make mistakes, but yeah. And if nobody has any more questions, then yeah, have a nice day, and yeah, I'll see you the next session.